This video is going to be all about the Musgrave texture. This node has quite a few settings, so we're going to spend some time just trying to familiarize ourselves with what the different parameters are doing when we change them. There's a lot going on here, so it can be a little bit complex. I was able to come up with what I thought were some pretty cool variations using this texture and some displacement. So I'm going to show you those variations in this video, and hopefully by the end you'll be more comfortable using this texture and you'll be able to come up with ideas much faster than you were before. Here's all the examples laid all out at once, some non-displaced images and some displaced images. Ken Musgrave is the man responsible for this texture, and you can see he actually died quite recently in December of 2018. But he was a computer artist who worked with fractal images. In the 90s, he designed software that could generate Earth-sized planets using semi-random procedural 3D, in which the user could fly or walk around the world, exploring mountains or forests, and then choose a scene to render to an image. This software was eventually known as Mojo World. You can actually search it on YouTube and get an idea of what it's like to navigate through the program, although from what I've read, it is kind of hard to get a copy of the original program. He also has some interesting cinema work credits, including Titanic, Dante's Peak, and Lawnmower Man. And he was even involved as a technical advisor of ZeniMax Media during the time of the release of Morrowind. So it's very cool to think that he might have been involved in some way with the design of that game. He's also got a website that you can check out, which is kind of cool, and he's even got a dissertation that you can link to off of his Wikipedia page. So here I am in Blender. I'm just going to split the screen and change the left side to the shader editor. Hit N to get rid of that shelf. Hit Shift A, start typing in Musgrave. I'm going to hit Control Shift and left click to get that preview going. And if that's not working, you just need to enable Node Wrangler by going to Preferences, Add-ons, type in Node, and just make sure Node Wrangler, that box is checked right there. And then on the right side, I'm going to hold down Z and move my mouse up, and I'll be in rendered mode. Now I can see the Musgrave texture. When I first started playing around with the Musgrave texture, I found it a little confusing. Things like scale, that's pretty self-explanatory. It just makes it larger or smaller frequency. And detail, kind of the same thing as a lot of the other textures. But then things like dimension and linearity, sometimes it feels like you adjust stuff and it doesn't really seem to make too much of a difference. Like if the dimension is turned up too high, for instance, the linearity doesn't really make a difference unless it's way lower. So, it can be kind of confusing to figure out what this is doing at first. I'm just going to go back to the default settings there, which is 5, 2, 2, and 2. I'm going to start out by looking at the default settings of the Musgrave texture. Up top here, we can select several different ones, and by default, it's on FBM, which stands for Fractal Brownian Motion. And a lot of the information I actually got from watching this video, so I just wanted to credit it. It was very helpful, and this guy explained very well, what the Musgrave texture is doing. So if you're curious, you can check it out. It's pretty interesting, but I'm going to be covering a lot of the same topics in this video. So for starters, Musgrave is actually multiple octaves of procedural noise combined. And detail, this one right here, is the number of octaves. So if it's 2, then it's 2 octaves. If it's 8, then it's 8 octaves, etc. Dimension is the amount of influence that successive octaves will have on the overall pattern. So if this is a higher number, then the next octave will have less influence on the texture. You won't really be able to see it. And then finally, linearity is the scaling factor between the different octaves. So let's explore that a little bit and just help you kind of see what those numbers mean, because the explanation is still kind of confusing, I find. I'm going to do something that was demonstrated in that video that I just referenced. I'm going to start off by going into edit mode by hitting tab and go to face select and just select that top face and hit G and then Z and hold down control so that it snaps to each point there. I'm just going to bring it down to kind of the origin level there. Tab out of edit mode, and you'll see that it's kind of stretched on the side because we're, as a default, going from the generated output of a texture coordinate node. So I'm going to, while I'm highlighted the Musgrave texture, I just hit Control T, and that brought up the texture coordinate and mapping node. I'm going to change this output from generated to object. Next, I'm going to modify the Musgrave. I'm going to change the detail to 8. I'm going to change the dimension to 0. And I'm going to change the linearity to 1.2. So what we have here is we have 8 octaves, and each successive noise octave is multiplied by a factor of 1.2. So basically, each successive octave is smaller and smaller detail. And so what I can do is if I were to change the dimension, for instance, each successive noise octave would have less influence. So if I turn this up it just looks like a regular Musgrave texture again. And if I were to change this to, for instance, 1, then each scale of the successive noise octave would just be multiplied by 1. So it's really just the same thing overlaid each time. So you really only get that if you are, slightly above 1, basically. 1.2, 1.3 looks kind of like it, but 1.2 is a good number to demonstrate this pattern here. So I'm going to attempt to create something similar with just noise textures. So I'm going to bring this texture coordinate down here, come out of Object, and let's bring in a noise texture and just place it right here for now. I'm going to create a little incision right here by holding down Shift and right-clicking and dragging through there. I'm just going to grab this noise texture and then Control-Shift-D to duplicate it 3 times. So we've got 4 noise textures there. This first noise texture is set to 5 for the scale. So the second one, I'm going to do 5 times 1.2. And I can even just type that in here like this. So it's just 6. Then this is going to be 6 times 1.2, which is 7.2. And this is going to be 7.2 times 1.2, which is 8.64. I'm going to bring in a color ramp and just place it right here. And I'm going to change this to constant just because it's going to be easiest to use. I'm going to bring this slider down to 0.45, the white slider. I'll just leave the black at the bottom. Then I'm going to duplicate this 3 times, so we've got 4 color ramps in total. And I'm going to plug the noise textures into that color ramp, making sure that we're doing the same output, whether it's factor or color. I just want to keep it consistent. So I'm going to use color and plug it into these 4 color ramps here. Lastly, I'm going to mix these all together. I'm going to get rid of that principal BSDF. I'm not really going to use it. So I'm going to bring in a math texture, place it here, open this up and hit M to change it to multiply. And I'm going to plug this into the bottom there. I'm going to duplicate this and just plug it, or plug these 2 color ramps into this one here. Then create a third, multiply, place it here, and plug this into the bottom. So here we can see we created something kind of similar to that Musgrave. It's not going to be exactly the same, but it will be similar. And in fact, we could maybe even change these to E's. And it's going to take a second to load in just because it's EV. But if I go like this and just change these to E's, I'm going to go out of rendered mode so it doesn't reload each time. That one to E's as well. Bring this up. And this last one. Let's check on that. So while this isn't exactly the same as this Musgrave texture, it's just made to demonstrate what's going on behind the scenes between these settings here, how they interact with each other. So I'm going to delete all of this here, and that color ramp as well. And let's just play around with this a little bit here. So again, detail is the number of octaves there. So if you turn this up, it becomes a lot more detailed, kind of the same way that the normal noise texture works anyways. And then this dimension here, again, successive influence for each octave. So if we turn that down, we have the most influence for each successive octave. And then linearity, again, is the scaling between the octaves. Most of the time when I'm using a Musgrave texture is to get something that looks kind of like this here. Detail around maybe 7 or 8, dimension around 0, 0.1, 0.2, something like that. And then linearity right around 2. I find this looks really good for kind of a metal, grunge, dirt type texture. I'm going to tab back into edit mode and move this face up to the starting point there so we don't really see the origin point anymore. We're just looking at the regular Musgrave texture. If we look at the Blender documentation, we can see FBM has this explanation here. Produces an unnatural, homogeneous, and isotropic result. Uses an additive cascade. The values are simply added together. If we were to look at another option, for instance, multifractal, we can see this explanation here. The result is more uneven, varies with location, more similar to real terrain. Uses a multiplicative cascade instead of additive. So I'm going to reset these to the default, so 2, 2, 2, 2, and let's check out multifractal. So what I notice is that it's kind of similar to the first option, FBM, except the values are a little lighter. And based on the explanation, I guess that instead of being added together, these octaves are multiplied together. So dimension, linearity are all going to do the same kind of thing, but it's a little lighter there. And from this video here, which is actually an older video, 6 years old now almost, I got a couple ideas of things you could try out. And one thing that looked pretty cool was if you change the detail to something around 11, the dimension to 2.1, and linearity to 0.9. Could also try bringing the dimension up to something like maybe 17.5, the detail to maybe 13 or 14, and then the linearity, let's change that to 0.7. Just a quick side note, when I tried to recreate this one, it actually wasn't showing up. I had to increase the linearity to 0.92 to get something there. And this had a lot of trouble rendering out. A lot of times it would just be a black screen. So I found that what fixed it was lowering the dimension to maybe 5 or something like that, and bringing down the detail a little bit as well to something like maybe 10 or lower. That might help you out. Otherwise, some really weird stuff was happening, and it wasn't rendering properly. So probably want to fix these settings a little bit. It's, had a lot of trouble for whatever reason on my system. The next option is hybrid multifractal, and it says that this one creates peaks and valleys with different roughness values, like real mountains rise out of flat plains. So it actually combines additive cascade and multiplicative cascade, which should be kind of interesting, although sometimes it's hard to find good examples here, so I'll just show you one from that video again that I stumbled across. I'm going to change these back to the default values to 2 and 2, and let's go to hybrid multifractal. So right away we can see that there's two additional parameters to adjust. There's offset and there's gain. The explanation for offset is it determines the level where the highest octave will appear. If you can see, if we lower this, it goes below 0, it turns everything black or darker, and if we move it up, it turns everything whiter there. The second one, gain, it's an additional multiplier to tune the magnitude of octaves. So it basically determines the range of values created by this function. So the higher number, the greater the range. It's a fast way of bringing out additional details in a texture where the extremes are normally clicked off. This can't go below 0. We can move it up, and we can see it adds a little bit more detail. These two options here aren't too obvious what they do yet. It'll be more obvious when we start displacing this. So one setting that gave kind of an interesting result is if we go detail 9.5, dimension 4, and linearity around 0.95. It looks pretty interesting. If you want, you can change the offset a little bit to do some cool things there too, or the gain. I'm going to reset these values again, change these to 2, offset to 0, and gain to 1. And let's check out the next option, which is ridged multifractal. So the explanation for this one is it creates sharp peaks, calculates the absolute value of the noise, creating canyons, and then flips the surface upside down. So this one looks pretty unique. I found some cool settings at basically the scale set to 3, the dimension to 10, that was the detail to 10, the dimension to 1.5, the linearity to 1.05, the offset to negative 0.18, and the gain to 6. It looks pretty interesting. That fifth option, heteroterrain or heterogeneous, I don't know how you say that, terrain, similar to a hybrid multifractal, but it also adds likeness of river channels. So basically peaks and valleys, different roughness values like real mountains that rise out of plains with the river channels as well. So let's switch over to that, and this is heteroterrain. There we go. And it doesn't really look that different to me than hybrid multifractal. Looks kind of the same. We don't have the gain anymore. I guess that's the main difference. Everything else seems fairly similar except for that gain. I'm going to try putting in those numbers that I used for that interesting hybrid multifractal pattern. The detail was 9.5, dimension was 4, and linearity was 0.95. So we get something similar here. It looks pretty cool, and we can change the offset if we want for a similar effect. Let's go back to hybrid multifractal, and you can see it is a little different. It'll probably be more obvious too once we start displacing it. So why don't we do that now? I'm going to delete our cube, and I'm going to change over to cycles. And if you have a GPU, you have this option here, GPU compute. For me, it works a little bit faster, so I'm going to put that on there. I'm going to hit Shift A and bring in a plane. And let's put that same material that was on our cube onto our plane. And I'm going to go back to FBM and just change these to the default settings, 2, 2, 2, with a scale of 5. I'm going to come down to the material properties and scroll down to where it says settings, and there's this option that says displacement, and it's set to bump only. I'm going to just change it to one of the other two. Displacement and bump is going to be fine. Then I'm going to come to the modifiers panel, and I'm going to add a subdivision surface modifier, change it to simple, and you know what, actually, let's go back to the render properties for a second and change this to experimental feature set, because that's going to give us the option to do adaptive subdivision, which I think will look a little cooler. Basically, it subdivides your mesh based on how close it is to the camera. So things that are larger in your viewport will get more details, and things that are further away will get less. So now let's take this height output of the Musgrave texture and feed it into a displacement node, just like this. And instead of normal, we want it to run into the height. So nothing's really happening yet, because we also need to run it into the displacement on this material output node. So we'll just do that. I'm also going to turn it down a little bit, maybe to something like 0.3, 0.4. That should work a little bit better. So let's take what we've learned so far and just look at these settings and try and figure out what's going on here. So the scale is 5. That makes sense. It's just the frequency. The detail is how many octaves there are. So there's 2 octaves. So if you turn that up to 3 octaves, 4 octaves, we can start to see more detail emerging already. The dimension, that's how much influence each successive octave has on this pattern. So if you turn that up, it's going to be very smooth. Even if this detail is cranked, it won't really make a difference. And if you turn that down, then the detail will be much more noticeable. You can see basically everything pushed up if we go down to something like 0. So I'm going to go back to 2. And lacunarity is the scaling factor between the octaves. So, something like 2 is going to be each successive octave twice the frequency of the one previous. 4 is going to be 4 times. You can see the detail difference. It looks kind of interesting. Much smaller detail on each successive octave when this is turned up. So this actually looks pretty cool for terrain, I think. Maybe if we turned this scale to 3, it kind of looks like rolling hills. Maybe turn this down to 0.2 for the scale. And the detail we can play around with here, maybe bring it up to 0.6 and bring the lacunarity down a little bit to 3 or 2 even. Looks really cool. I think this looks pretty realistic already, and it would be a good starting point to start adding more details for something like mountains or hilly terrain. If I try and do that same grunge texture, it's not really going to work quite as well, but let's try it anyways. So a scale of 5, detail of 8, the dimension is going to be 0.1, and the lacunarity, I'm going to leave it at 2. So we can see that it looks very messy, very hard to see what's going on here. Maybe if I adjust something, it'll be a little easier, but even still, in fact, let's look at this thing here too, the thing we were looking at before, where everything's kind of a radial pattern almost. It doesn't really have the same thing going for it when we're using displacement. It works a lot better for kind of a grunge texture on a flat object that's maybe going to influence maybe the bump or the roughness or something like that. So let's explore the next option. First, I'm going to reset these values to the default values there. And if we look at this explanation for the next one, multifractal, the result is more uneven, varies with location, and more similar to real terrain. So let's swap that over to multifractal. We have all the same parameters here, so let's try playing around with these a little bit. Maybe go to 4, maybe dimension to 2 is probably fine. And we could play with the lacunarity a little bit, maybe up to 4 or something like that. Maybe crank the detail up a bit more. It looks fairly similar to the first option, FBM, to me. I'm not really getting a huge difference here that's standing out to me, but it's interesting. In fact, if you bring this dimension down a little bit, I think this looks really cool. Very interesting terrain-looking stuff here, mountains or something similar. We can bring this down to 0.1 to have it a little bit less exaggerated as well, and it looks quite cool. You can see if you bring this dimension down too, it starts to go a little crazy. Right around the 0.8 mark, starts to kind of look a little bit too jagged for most realistic terrain. But right around this point here, it does start to get pretty interesting. You get some interesting terrain coming up here. I think there could be a lot of uses for something like this. I'm going to reset these values to the defaults. And let's explore the next one, which is hybrid multifractal. And let's remind ourselves what that is again. So creates peaks and valleys with different roughness values like real mountains that rise out of flat plains. So this one should look a little bit more like terrain. Let's see if we can make it look more realistic there. And offset, I'm just going to put that at 0. So one setup that I found looked pretty good was leaving the scale at 5, setting the detail to 8, the dimension to 0.4, the linearity to 4, the offset to 0.27, and leaving the gain at 1. I thought it made some pretty cool mountainous terrain here. Let's take a look at ridged multifractal next. And if we look at the Blender doc, we can see the explanation is that it creates sharp peaks, calculates the absolute value of the noise, creating canyons, and then flips the surface upside down. I mean, it sounds cool. Let's see what we can do. I found I had pretty good results with something like this here, setting the scale to 3, the detail to 10, the dimension to 1.5, the linearity to 1.05, the offset to negative 0.18, and then I kind of cranked up the gain a little bit to about 6. And then it's a little bit too much of displacement level, so I'm going to drop this down maybe to 0.05 or something like that. This is actually the setup that I had in the intro there as well. What I did is I changed the X offset here, I guess the X location to -2, just to kind of make it not in the middle there. And then I changed this Z location, just kind of animated it. So on frame 0, I had it at 0. So I'm just going to set a keyframe there. And then at frame 320, I had it at a value of 1. So I'm just going to set another keyframe there. And I'm going to lift this up and just hit V here and hit vector so that it's smoother interpolation. Otherwise, it starts slow, goes fast in the middle, and ends slow. So what we can see here is it just kind of rises up kind of slowly, creates this interesting effect here. And then what I did too is to give it a little bit more complexity, I also enabled this Z rotation here. I animated that value there. So again, at frame 0, I'm just going to click that and add a value of 0. And then at frame 400, I had it at a value of 90. So I'll just set another keyframe there. And then I'll just make sure I grab all those keyframes by hitting A twice and then hitting A one more time, hitting V, and then selecting vector again. And then we've got this interesting animation going on here. The last one on our list is hetero terrain, so I'm going to swap to that here. And let's turn this up to about 0.5, just in preparation for that. And let's check out the explanation. It's similar to hybrid multifractal, creates a heterogeneous terrain, but with the likeness of river channels. So let's see if we can make that one look cool too. I looked the result that I got by setting the scale to 1, the detail to 6, the dimension of 0.42, the linearity to 3.2, and then the offset to -1.6. Kind of gives a bit of areas here where there is no detail, and then a lot of other areas where there is detail. I'm going to bump this up to 0.6 as well, just increase the displacement slightly. Another setting that I liked with hetero terrain was setting the scale to 3, the detail to 5, the dimension to 10, the linearity to 0.8, and then the offset to -0.5. And it looks a little crazy here. I'm going to bring in a color ramp and just place it right here, just to kind of constrain it a little bit. And then let's go ahead and just turn down this displacement here, maybe 2.2 or something like that. And it looks a little strange with this displacement shader, so I'm just going to bring in a principled BSDF, place right here, and let's just look at it through that. And I'm going to turn off the adaptive subdivision as well. Just crank up these subdivisions here to something like 6, and I think this looks a little bit better. Let's also look at another multifractal, one that I came across that I liked the look of. First of all, if you just switch it over and keep these settings, that does look pretty cool, but I'm going to swap these out a little bit. I'm going to change the detail to 3, drop the dimension down to 8.5, And the lacunarity, I'm going to bring that to 0.86. And there we go. If we turn on our adaptive subdivision, we can see it's nice and smooth as well. We get these shapes here. It does look a little weird here, so you might want to crank up this dicing scale a little bit if you want that smooth, but just an interesting terrain here. We have these sharp channels coming through. Just show you some other things I came up with involving this ridged multifractal setting here too. And to do that, I'm just going to bring in a facing node. No, that's not right. A layer weight node and come out of Fresnel or facing, whichever. And I'm going to bring in a color ramp. Actually, let's do Fresnel. Let's do that. And I'm just going to feed this into the base color here. And let's look at that there. It's not really anything special just yet because I had to adjust some stuff here. So what I'm going to do is I'm going to set this to 0.5, 10, 0.5 for the scale, 10 for the detail. The dimension is going to be 0.2. Lacunarity is going to be 1.7. Offset is going to be 0. And gain is going to be 25. Yeah, so interesting little terrain here. If I turn this off, I think the terrain looks pretty cool like this too. Maybe set it to smooth shading. But adaptive subdivision does look pretty good as well. Maybe let's just turn down the scale on that displacement a little bit. And then we can tweak this setting here if we want, just to get a different effect with that Fresnel. But actually the default looked pretty good there. I'm going to change some of the settings here to show a different setup I came up with as well. Change the scale to 3, the detail to 2, the dimension to 2, the lacunarity to 1, the offset to 0.3, and the gain to 1. And now we have these, interesting little sharp ridges running through here. Interesting little pattern there. And if you bring the offset down to 0, you see it's just these hills. And if you bring that offset slowly up, you see the ridges come up between those hills, which is pretty interesting. Okay, that's it for today. Hopefully that was helpful and it helped you familiarize yourself a little bit more with the Musgrave texture. I know I found it confusing at first, so exploring it really helped. And I recommend you do that. Just explore the possibilities, see what you can come up with, and maybe you can come up with something way cooler than what I did in this video. If you have any questions, let me know in the comments, and thanks a lot for watching.